All right, let's talk about vertical stretches. And it might be a good idea to look back at the last video on the horizontal stretches or shrinks. When you have a problem in the form y equals a times f of x, like this one, h of x, which is another way, it's a function notation for the y, that a is a 3, and it's outside of the f of x. In the horizontal one, the a was inside the parentheses. On this one, the a is in front of the f of x, okay? So if you see that, it's going to be a vertical stretch or shrink. It will be a stretch if a is greater than 1, but it'll be a shrink if it's a fraction between 0 and 1, a proper fraction. Your factor is a. Now, keep in mind the horizontal one, these were backwards. It was a stretch if it was a fraction, it was a shrink if it was greater than 1. So those are different. And the factor on the horizontal one was 1 over a. So there are differences there you need to note. Let's go ahead and graph the parent graph, x minus, I think I wrote something down wrong. It was x minus 1. Let me fix that. X minus 1. All right, so I'm going to go down to 1. And that is my y-intercept. And then my m is the invisible one. So I'm going to rise 1 and run 1 right, rise 1, run 1 right, rise 1, run 1 right. And graph my parent graph. Same one for the last equation. Okay, that is my parent graph that we call f of x. Now, to graph h of x, what we're going to do is look at these points here that we have for the parent graph. Here's one where the x is 0, the y is -1. Remember, this is also could be called the y. Where the x is 1, the y is 0. And where the x is 2, the y is 1. So there's 3 nice ones that we can work with. All you have to do is multiply the f of x by 3. So very simple. -1 times 3 is -3. 0 times 3 is 0. And 1 times 3 is 3. Okay? We have it now. We'll take this x and these x's and these 3 f of x's to find our ordered pairs to graph for the h of x. So the first one will be 0, -3. We'll have one at 1, 0. And we'll have another one at 2, 3. Let's graph those. 0, -3, 1, 2, 3 right here. 1, 0, right 1 right here, point on a point. And then 2, 3, so right 2 up, 1, 2, 3. There we go with our h of x. So they're probably going to ask you what this is, and you say that it is a vertical. The reason it's vertical is because the 3 is outside in front of the f of x. It's going to be 3 is bigger than 1, so it will be a vertical stretch. And then the factor is a, which is 3. Factor 3.